Okay, today we're looking at composite shapes. What we're dealing with when we're talking about composite shapes, um, looking at composite shapes, we use, composite shapes are irregular. You know, when we're finding the area of a rectangle, that's easy, length times width. When we're looking for area of a circle, you know, pi r squared, we do that. However, sometimes we have shapes that are not perfect polygons, as far as being regular polygons or quadrilaterals or triangles. For instance, look at A. How would we go about finding the volume or the area of this figure right here? Well, what we can do is we can break this down into two figures that we do know how to figure this out for. For instance, if we look at this rectangle, it's got dimensions of 11 by 3. Well, the area of that red rectangle, we would multiply 11 times 3 and get 33. Well, if we were trying to find the area now of this rectangle, we would have to say 11 minus the 8 would give us this dimension right here. And then 5 minus 3 would give us this dimension, which would be 2. So that gives us a rectangle that's 3 by 2. 3 times 2 is 6. So we add 6 plus 33 and end up with an area of 39. We don't have any units, so we'll just call it units squared. And that's how we go about finding this composite shape, the area of it. You know, if you're laying carpet, this would be a thing. You know, rooms aren't made in perfect rectangles, but you still have to know how much square footage you're laying. So, you know, here's another example. We've got the shaded square. The shaded square would be the large one. So what's the area of this large rectangle? Well, 12 times 24 is 288. Well, the problem is we don't want to include this unshaded area. The area of that rectangle is 4 by 8, so it's 4 times 8 is 32. So if the whole thing is 288, we want to subtract 32 square feet from that, and we end up with 256. We don't have any units, so we'll just call it unit squared. Okay, then we have another one dealing with rectangles, right here. In this problem, what I would do is I would break it down into smaller rectangles, basically 3 smaller rectangles, because we know how to find the area of rectangles. Notice all these sides are congruent, which if the whole thing is 27, we divide 27 by 3 and get 9 for each of these lengths. Same thing on this side. These segments are all congruent. It's 18. Well, 18 divided by 3 is 6. So, let's find the area of this rectangle first. It's got dimensions of 6 by 27. So 6 times 27 would be 42, 162. Okay, now we'll find the area of this rectangle, which has dimensions of 6 by, well, this length right here is 9 plus 9, or 18. 6 times 18 is 108. Okay, and then the last one we'd be looking at this rectangle right here, and it's 6 by 9, 54. So we know the area of all 3 rectangles. Now we just add them up. 162 plus 108 plus 54. And we get 324. Again, no units, so we'll just call it unit squared. Okay, the next word problem says that there's a putting green that is, they're deciding how much carpet. It's putting green for a miniature golf course. We have to find how many feet of carpet are needed to cover this green. Well, we've got 3 different shapes. The first shape is this rectangle. This rectangle is 4 by 7, which means it has an area of 28. 4 times 7, length times width is 28. Well, we also have this half circle. This half circle, notice, has a radius of 4, and the area of a circle is pi r squared. So it's going to be pi times the radius, which is 4, squared. So 16 pi. But also notice it's not the entire circle. So we're going to take half of that, so we're going to divide it by 2, which ends up giving us 8 pi. And if we get 8 pi and find out what 8 pi is as a decimal, 8 pi is 25.1 basically. So the area of that half circle is 25.1. Now we have a triangle right here. It's a right triangle. So what we're going to end up with is we need to know, we have a base of 4 feet. We need to know what the height of it is, this right here, so that we can use the formula, which is 1/2 times base times height. So that would be 1/2 times 4 times whatever we get for x. Now we can solve this with the Pythagorean theorem. 4 squared plus x squared equals 5.7 squared. When we do that, we end up with 16 plus x squared equals 32.49. Subtract 16 from both sides, and x squared equals 16.49. Take the square root, and x equals, rounded, 4.1. So if x equals 4.1, we multiply 1/2 times 4 times 4.1. And when you do that, you get 8.2, which is the area of this triangle. Now we add up all three numbers, and when we add those three numbers circled, you should get 80, let's see, 20, 40, 53, 61.2. And we're talking about square feet. Okay, so this irregular shape, we're able to find the area of it by using what we know about the area of figures. Now here we have another one we're finding the area for. First of all, this is a rectangle. We're finding the area of the shaded section. So the area of this rectangle is 5 by 6. 5 times 6 is 30 square meters. Now we don't want to include this unshaded area, so we need to find the area of this triangle. Well, we know the area of the base is going to be 6 because opposite sides of this rectangle are congruent. So the area is going to be 1/2 times the base, which is 6, times the height, which we don't know what that is. Now it's right triangle. That's 4. We also know that since it's isosceles, it's going to have, the altitude is going to be congruent. So this is going to be 3, and that's going to be 3. So we end up with the triangle, and I'll redraw it, with a side of 3 and a side of 4, and we're trying to find out what x is. Pythagorean theorem says square the legs, set it equal to the hypotenuse squared. So 9 plus x squared equals 16. X squared equals 7. Take the square root of that, and we find that x equals 2.7. So now we use 2.7 as the height. So 1/2 times 6 times 2.7. Let me do that. you should get an area of 8.1. Now remember, that's the triangle that's unshaded. So we take the rectangle, which was 30, subtract 8.1, the triangle, and get 21.9 meters squared. That's the area of the shaded section. Okay, those are all the notes for this. Let's look at the first page of the assignment. Okay, for the first problem, you're going to divide that up into rectangles. For the second, you're going to find the area of that rectangle and then just subtract the area of the triangle right there. Very similar to the problem we did in the notes section. Here you have a rectangle and a trapezoid, which you're going to find and add together. 15 has a rectangle and a triangle, which you'll add. Number 16, you'll divide up into 3 different rectangles. Number 17, that's a trapezoid and 3 half circles. So you're going to have to find the area of those half circles. Number 18, you have 2 rectangles and a fourth of a circle. So you need to find the area of a circle and then divide it by 4 to find the area of that section. Number 19, you have a square. You're going to subtract the area of the circle. And number 20, you have a rectangle, which you would divide here, and a triangle, add them together, but then also subtract this half circle. And the last 2, you have 29 and 31. Number 29, you'll find the area of this rectangle, subtract the area of the half circle and the area of the trapezoid. Number 31 is kind of tricky. You have a square here, find the area of the square, and then find the area of the triangle formed in this section. And whatever the area is of that, you've got 4 of those triangles. So you multiply that area times 4 and subtract it from the entire square. Alright, hopefully that helps on those problems. Good luck.